I'm going to begin by talking about common WAN components. First up are copper line drivers or repeaters. These are used to allow network traffic to go farther distances over copper wire type networks. They take an incoming signal and regenerate it, boosting the strength of that signal, and then they send it back out, thus reducing attenuation. Common to all WANs is the Demarc. Demarc stands for the demarcation point. This is the physical point where the telecommunication company's responsibility ends and the customer's begins. The telco takes care of the upstream end of the network, and the customer takes care of the downstream end of the network. The Demarc may be simple or it may be very complex, depending upon the size of the organization and the required services. Then there is the Network Interface Unit, or the NIU. In the SOHO environment, the NIU is usually the Demarc. Also in the SOHO environment, the NIU is usually provided by the Internet Service Provider, or ISP. An NIU can be a cable modem, a DSL modem, or another piece of hardware that connects the customer to the ISP. One type of NIU is the Smart Jack. It's an NIU that can provide feedback on conditions to the ISP. Smart Jacks help the ISP determine if a problem exists on its end of the Demarc through the use of remote loopback capabilities. Many Smart Jacks can also provide translation between protocols, as in translating a serial PPP communication stream into Ethernet. More than likely on larger networks, you will find CSU DSUs. That's Channel Service Unit, Digital Service Units. This is the interface point that provides the connection between a point-to-point line and the device that is directing network traffic, which is usually a router. The CSU DSU may be an external device, or it may be a removable module inside of a router. Only two CSU DSUs may exist on a single point-to-point line, one at either end of the connection. With the common components covered, let's move on to common wide area network issues. First up is a loss of internet connectivity. Many factors can lead to a loss of connectivity on both sides of the Demarc. Before contacting the WAN provider, check the local area network equipment for its operation. If the issue is not to be found on the LAN side, then contact the wide area network provider. One of the tests that the WAN provider will conduct is a loopback test to check its line for interference. DNS issues are also common in a WAN environment. They may look like a loss of internet connectivity, but it isn't. The users may complain that they cannot connect to an outside source like www.google.com, but it may not actually be a connectivity issue, but a DNS issue. If using a local DNS server, verify the settings and make corrections accordingly. If the network is using the WAN provider's DNS settings, attempt to ping the IP address. If that works, there is a WAN connection. If you then use the ping utility with the fully qualified domain name and this fails, then contact the WAN provider to resolve their DNS issue. Interface issues are also common. Errors on a router's WAN interface can indicate several different issues. Monitoring an interface's status and reading the error reports may provide a clue as to the issue. The most common issue that prevents a good connection is a speed or duplex mismatch. A speed mismatch between interfaces will prevent a link from being established. A duplex mismatch between the interfaces will create errors, as in output and input errors. If you're experiencing discards and drop packets, there's a couple of things to consider. If the device is discarding incoming packets, then more than likely the device's CPU is being overutilized. It may be time to upgrade. If the device is dropping outgoing packets, then there is a bandwidth congestion issue, which may be caused by interference on the line. So either you may be trying to move too much network traffic, or there may be an issue on the wide area network provider's side of the line. Router configurations are a common problem when establishing a new WAN connection. A misconfiguration of the WAN interface of a router will lead to, guess what, a WAN connection issue. If this is suspected, verify the proper configuration settings with the WAN provider. Unfortunately, company policy and practices sometimes get reported as a wide area network issue. Some applications may be throttled or have their available bandwidth reduced for quality of service reasons, leading to slow service, which is a perceived wide area network issue. Also, acceptable use policies may restrict or block access to certain sites or types of sites, which may appear to the end user as a WAN issue. There's not much that you as the technician can do to resolve this, but it is up to you to explain it to the end user. A satellite wide area network connection may also become an issue. If a satellite WAN connection is used, latency will increase due to the distances covered by the transmissions. Latency is the measure of time between the sending of data and the receiving of the data. Careful application of quality of service techniques may mitigate the effects of latency on some applications, but you're still going to have more latency with a satellite connection than other types of connections. Split horizon is another issue. Split horizon is a technique used in routing to help prevent routing loops. With split horizon, a router will not advertise a route to another network out of the interface that it learned the route on. With a point-to-multipoint wide area network connection, the router may have difficulty with split horizon. It will learn all of the routes available to it on the same interface, but it can't advertise those routes back out of that interface. Creating logical sub-interfaces on the wide area network interface will usually resolve this problem. The logical sub-interfaces appear to the router as individual interfaces, allowing the router to advertise the routes back out of the WAN interface.